Distance, speed, and time. Let's have a look at this question. Jacob takes part in a race, which involves kayaking and running. He must get from the point S, so that's where he is, in the sea to the point F on the coastline. So that's where he is going. Even by looking at this drawing, we know that he can go two ways, isn't it? He can either go from S directly to F, or as this place is suggesting, go straight and then go along. Just two ways of doing it. A is another point on the coastline, and then we have measurement from S to A is 2, from A to F is 8, and then they are saying this is a right angle. Now, when we see a right angle triangle, the drawing, even without reading the question, what do we think about? We think about page 16 in our maths table, because that's where we have formulas that has to do with right angle triangle and not right angle triangle. Now, page 16, majority of that we are using in paper 2, but we are using it as well in paper 1. So apart from your minus b formula for solving the quadratic equation, find the roots of quadratic equation, page 16 and usage of that formula is the second most common thing we use in our exam. Okay, Jacob kayaks at an average speed of 6 kilometers per hour and runs at an average speed of 12 kilometers per hour. Right, okay, so your trigger word, speed. In your exam, you're going to have only two types of situation when you see the word speed. That either you are thinking about formula that has to do with distance, speed, and time, or this is a function of speed and time, my variable. Now, how do I know that this speed doesn't refer to the function, but refer to the formula of distance, speed, and time? Because as we can see here, there is no function given. So we know that doesn't refer to the function of speed and time, but to the formula that is distance, speed, and time. Okay, so we have speed of kayaking, and then we have the speed of running. Okay, so what is that we have to do? Find how long, that means I am looking for what? Time. It will take Jacob in total to kayak from S to A, so by the sea he kayaks, and then he runs along. So how do we find time? That is distance divided by speed. One thing we always have to be careful in questions that are referring to these formulas is the measurement, okay? So what is the distance that he is going to kayak? 2 kilometers. And what is the speed of kayaking? 6 kilometers per hour. And, therefore, plus, he's going to what? Run. What is the distance of running? 8 kilometers. And what is the speed of running? 12 kilometers per hour. So there is, like I'm saying, the reason why I wrote that so that we understand that our measurements are correct. We don't have to change anything. How does the measurement work? So I have kilometers that are divided by kilometers per hour. When I am dividing fraction, I multiply and turn my second fraction upside down. And what happens here, kilometers divided by kilometers are 1. 1 multiplied by hour is hour, so our answer here will be hours. So when I put in my calculator 2 over 6 plus 8 over 12, I get 1. So that is 1 hour. That's how long in total it will take him to go from to kayak and then run. Okay, let's have a look at next part of that same scenario. So next part is saying find how long, again, how long, that means we are looking for time. That means that will be distance divided by speed. It would take Jacob to kayak directly from S to F, correct, to the nearest minute. Like we said, that's the second available route. He's going to kayak directly. So speed we know the speed of kayaking, 6 kilometers per hour. That's fine, 6 kilometers per hour. However, the problem is we don't know the distance. And that's where our page 16 comes in. We have a right angle triangle. In our table, page 16, that refers to right angle triangle is at the bottom of that page. The top page has to do with not a right angle triangle. We have two formulas to choose from to meaning Pythagoras and trigonometric ratio. How do we make that choice? Well, Pythagoras formula has three elements. My a square plus b square equals c square. Each of these letters represent a side or a length of a side of a triangle. And then trigonometric ratio, doesn't matter which of them, cos, sin, and tan, they all have the same element. Note in your table you have capital A, which means angle. And then you have two small letters, either A or B, B or C, C or D. Sorry, there is no D. They represent the side of triangle. So when I am choosing the information, I'm saying, yeah, let's just write this, what we know. So what is that I'm looking for? I'm looking for this distance. So I am looking for a side. What information I have? 2, that is a side. I have 8, that is a side. Nothing for me in trigonometric ratio, Pythagoras it is. So what will be my A, B, and C in this particular triangle? C is the side that is opposite the right angle, so actually the side I'm looking for, that will be C. A and B in Pythagoras, doesn't matter which of them is A, which of them is B. Why? Because we are adding them here. So that means that this C, if I'm looking for C, not C to the power of 2, what do? I take a square root of the other side, isn't it? So that means that this value will be what? 2 to the power of 2 plus then 8 to the power of 2 under the square root, and we know that that measurement will be in kilometers. And again, it's enough for us to put that. We don't have to do work, like I don't have to find the value here. I don't have to, because that's not my answer. If I put the numbers in my calculator, press equal, I have 1.3743 of an hour. Terms and condition of my answer to the nearest minute, I need to find out how much minute is that. How do we do that? 0.3743 multiplied by 60 minutes, because we are looking for a part of an hour. So that will give me 22. So it is 1 hour and 22 minutes. That's our answer here.